This will be a simple demonstration of a simple tube connection. Connecting a tube with the heater wires and the cathode and the grid and the plate wires. To start with, we've got an AC power, a small Radio Shack transformer, 12.6 volts, center tapped at 6.3 volts. I'm going to take the 6.3 volts to the black and red twisted pair, which is going to heat the tube heaters. This tube is burning my fingers right now because it's quite hot. And once you have the heater connections, this is a triode. So you've got a cathode grid plate on one side and a cathode grid plate on the other side. So it's two tubes in one package. See the tube down inside there. It's quite hot. And just for a simple circuit to power it up, we're going to be using my 90 volt power supply, which is 10 9-volt batteries in series with electrical tape holding them all together. So you have 5 on that row and 5 on this row, and they're all snapped together. So over here you have a minus side, and over here you have the plus side, and you put in a meter on that, and you get somewhere between 90 and 99. I've been getting like 98, 99 volts. That's my DC high voltage power supply. This is a little circuit setup to make the tube connections easier. Just quick description. This loop right here is going to be ground. 2 resistors here. The top resistor, 2.7K. It's going to be cathode resistor. Behind that one, there's a 1 meg resistor, which we're going to use to pull the screen, the control grid, down to ground with a 1 meg resistor. Then we have another ground here. This resistor is 100K. It's going to pull the plate, float the plate up to around 80 or 90 volts. We have a capacitive coupled for the output, sound output. And this resistor is going to float the output leg of the cap down to ground, because if you don't do that, if you don't float that leg down to ground, it could literally float up to 100 volts. And if you touch that or try and hook that to your input without floating it down, you're going to send a 100 volt surge into your input system. So cathode resistor, grid resistor, plate resistor, and just an extra pull down resistor for the output cap. And this is just a jumper wire. The jumper is for my ground connections. Could have done it without the jumper, but I left it in there. So we have a transformer, we have a tube that's hot and ready to go. Got a setup circuit, and we've got a 90 volt power supply. Next step, I've connected the 90 volt power supply, attached the negative black lead to what I'm using as a ground, and the plus yellow lead is going to be my plate. It's going to float the plate up to about 80 or 90 volts through this 100K ohm plate resistor. Okay, next step. Yellow wire is the cathode, blue and green wire is the grid, red wire is the plate. Yellow wire cathode has a 2.7K resistor to ground. The green wire, which is the grid, has a 1 meg resistor to ground. The red plate wire is going to have a 100K pull-up resistor to B+. And here's how you know if the tube is doing its job. Using the voltmeter, I'm going to look at B+. You can see the B+ is 98.6. And then if we go and measure the plate, which is the red wire hooked to the plate, it's measuring 75.1 volts. So that shows us the tube's conducting. If the tube were not conducting, the plate would be reading 98.6. In fact, if we disconnect the plate wire to simulate the tube not conducting, you can see on the plate resistor you have, okay, now the voltage has changed slightly, 99.1 on the one side of the plate resistor. The other side of the plate resistor, which is now connected to nothing but a capacitor, 98.1. So all the voltage is transferring from the B+ to the other side of the resistor. When the plate connection is connected, when the tube begins to conduct through the resistor, you'll notice the 98.6 for B+, and then if we go over to the plate, it drops down to 75.1. That tells you it's conducting, so there's current flow. Something is drawing current through that resistor right there, between the B+ and the plate. Another measurement to show you that the tube is conducting, the 2.7K resistor that connects to the cathode. It's going to be 0 volts on the ground side, and then over on the cathode side, we measure the cathode. You'll notice it's 0.6 volts. That means there is current flow through the cathode. So there you have it. It's can't get much simpler than that. This is a dual triode. We're using one side of the triode. It's a 12AX7 tube. This is all these goodies are all Radio Shack. Batteries came from the 99-cent store, I believe. Don't remember where the multimeter may have come from Walmart. The power strips are Radio Shack, connecting leads are Radio Shack, resistors and caps are Radio Shack. The tube and the tube holder were ordered from online. The transformer is Radio Shack. It's 0.45 amps or 450 milliamps, 6.3 volts AC. And the line cord was just I believe it was an extension cord from the 99-cent store, which I cut and tapped into my barrier strip here. So hope that helps understand tubes a little bit. With just those understanding those basic readings and current flow, you could actually go inside of an amplifier if you were careful and be able to tell if each section of the tube was conducting just by looking at the cathode voltage and the plate voltage and the drop across the plate resistor. So here's something you could try at home, not very expensive. It's a lot of fun and lots of luck with that.